So carrying on from our video in part 1, I'm now going to just show you how you will solve a situation where you've got connected particles with a known tension and acceleration. Now what you need to be aware of here is you treat this situation as two different entities. First of all, one would examine the left hand side of the model given by this section here, and then what we would do is we would also examine the left hand side given by that situation here, as if we didn't know what was going on either side. Now obviously we're dealing with forces, masses and accelerations, so what we just do is we apply F equals ma in the direction of motion. So if I was going to look at the left hand side and I was going to apply F equals ma in the direction of motion, which is upwards, the only force that's acting up in this situation is the tension. So we'd have tension acting upwards, we'd have the 3g acting downwards, and that would equal mass times acceleration, which is 3a. If we're now going to apply F equals ma on the right hand side, it's moving downwards, so the force acting downwards is 5g. Take away t would also be equal to 5a, mass times acceleration again. Now as you can see, we've got two equations with two unknowns that are actually linked. What we'd normally do now is we would set up a substitution. So if I was going to take the left-hand equation, for example, I could rewrite that as t is equal to 3a plus 3g. And I could take that equation now and use it as a substitution here. So if I was substituting in, I'd have 5g minus 3a plus 3g is equal to 5a. Now obviously we'd need to be careful of signs here, so we'd have 5g minus 3a minus 3g is equal to 5a, and then we just need to gather our terms. So for example, we could do 5g take away 3g is 2g, and obviously add 3a to both sides, that would make 8a. So 2g upon 8 would equal a, or 2 8 is a quarter, so g divided by 4 ms to the minus 2 is a. And leaving it in this form, in the exam they may ask you to write it to 1 or 2 decimal places, so that would just be an easy calculation on your calculator. So now that I know that acceleration is g divided by 4 meters per second, I can then take that and sub it back into my tension equation. Because we did a rearrangement earlier, so we know tension in terms of acceleration and gravity. So we're going to have t is equal to 3 lots of g divided by 4 plus 3g. So if you wanted to gather those together, obviously 3g over 4, and that 3g would be equivalent to 12g over 4. So the tension would be, in this case, 15g divided by 4 newtons. And again, you may